Here we are on the section on word problems, numbers 36 through 39, dealing specifically with proportions. Proportions are nice because, well, you always have the same proportion. It gets a common ratio. In number 36 here, we have a 5-foot boy casts a shadow 7 feet long, so the 7 feet long. And we have over here a 9-foot tree, and that's our X. We don't know what that is. So we're like, oh shoot, what do we do? A 5-foot boy casts a shadow 7 feet long, 9. And so this is where a proportion comes up, that this is going to be a common ratio, that whatever we times 5 by to get 9, we're going to times 7 by to get X. So there you can write this out in two different ways. You can say either 9 is to 5 as X is to 7. Let's write that out. 9 is to 5 as X is to 7. Or you could write it out and say 5 is to 9. Let's put this down here on the bottom. 5 is to 9 as 7 is to X. Notice that you have the 5 matching up with the 7, the 9 matching up with the X. So this one is saying, ooh, 5 divided by 9, that would be what would be the ratio, common ratio coming back. And that's perfectly fine if you want to do that. This one's a little bit easier because when you solve it, you just times by 7, and you now have the answer of X has to be 63/5. And you're all done. Down here, notice we would have to clear out the fractions by timesing by 9x, timesing by 9x, 9's cancel, x's cancel, great, 5x equals 63, and then we would get x equals 63/5. Very interesting thing here, you will note that 5/9, if you reciprocate it, goes to 9/5, and 7 over x could be x over 7. Something that we don't often teach in math is that a reciprocal of both sides is the exact same thing. I mean, it's a legal operation. If two quantities are equal, their multiplicative inverses must be equal as well. So we can do that. And that may help us out on a few of these others. Let me see, number 37. There are two similar triangles. So one has 5, 9, and 11. So if we draw that triangle, let's draw it out over here. 5, 9, and 11. And the other guy is corresponding side. So 8 corresponds to 5. So 8. The next one corresponding to 9 is x, and y corresponds to 11. Okay, so there's where we go. So again, since they're similar, this means there's a common ratio. So if you take 8 divided by 5, it has to be the same thing as x divided by 9. So let's write that out. 8 over 5 equals x over 9. Now, can we solve that for x? Sure, times by 9 and we get 72/5 equals x. Excellent. Now, you should note that if you did it the other way and wrote 5 is to 8 as 9 is to x, that's perfectly okay. No worries at all. If we times by the common denominator of 8x, we will get 8x, 8x, 8 cancels over here, x cancels over there, and we get 5x equaling 72, and again the same answer. You may see this as cross multiplication, and you are right. Anytime you have two fractions equal each other, you can cross multiply, and it works very well. Here you could even cross multiply. 72 equals 5x, but then you'd have to divide the 5 back. The other thing you should note is that you have reciprocal. We'll get that x up on top and make it easier. Cool. Let's do that other guy in a similar color, but a little bit different, and try to get the y. We're trying to get y, so I'm going to put him on top. Y is to 11 as 8 is to 5. Can we do this? You betcha. Times by 11, and you get y equals 88/5. Excellent. There's x and y. All right, number 38. The ratio of males to females is 2 to 7. Now these two dots can just be written 2 to 7. Male to female. And the idea is it has to keep this exact same ratio. So 2 to 7. If there are 12 males, how many females? I'm going to put an F there. Now, notice the F is on the bottom. We could times up here and times up here, or we could reciprocate both sides and write, oh, 7 females to 2 males has to be the females to 12 males. Times by 12 on both sides. And we get 12 times 7 is 84 divided by 2. The number of females is 42. There we go. And you can kind of see that if you're timesing this guy by 6, then the number of females would have to times by 6 as well. That's the whole idea that we're doing here is, oh yeah, look at that. That makes sense. Okay, so right up here, the ratio of factory workers to supervisors. Oh boy, factory workers to supervisors. Notice that they're both employees is 9 to 2. So if we were to write 9 workers to 2, and that's supervisors, notice when we come over here, there are 77 total employees. So we're asking how many workers for 77 total employees. We have the wrong number down here. They were tricky. We got to do this all over again. They're doing 77 total employees. So really, if there's 9 to 2 ratio, then workers to total would be 9/11ths. Can you see this in this little group? That if you had a little group here and you had 1, 2, 3, 4, 5, 6, 7, 8, 9 workers, factory workers, and 1, 2 supervisors, then the ratio of factory workers to total employees is 9/11ths. So yeah, 9/11ths is the ratio of factory workers to total employees equals X to 77. Oh, good. Now that makes sense. We can do this because they were starting to try to compare apples to oranges, and that wasn't working. So now we have workers to total employees, workers to total employees, times by 77, times by 77, and we get X equals, let me see, 77 divided by 11 is 63. Oh, that's right. Now if they asked how many supervisors, let me see, there are 77 total employees, so it'd be 63. So times by 7, 63, and 14. Excellent.